Now let's do this example. Find global max or global mean for this function. So how do we find the global max or global mean? We find out the critical points and we find the value of the function at critical points and at the boundary, and see which one is the maximum, that is the global max, which one is the minimum, is the global mean. Okay, let's do that. So f prime, oh, this is basically f over g form, right? Do you know the formula? It is f prime times g minus f times g prime over g square, right? So let's do that. F prime is 12x minus times g is x minus 2, and then minus f is 6x square times g prime is 1, right? This is the derivative of x minus 2 is just 1, divided by g square is x minus 2 square. So if you simplify, what do you get? 12x times x is 12x square minus 24x minus 6x square divided by x minus 2 square. You see that? So what do you get? You basically get 12x square minus 6x square is how much? So can you tell me how much is that? Basically this will be 6x square, right? So it will be 6x square and then minus 24x over x minus 2 square. Can you factor out something on the top? Basically, yes. So if you take 6x out, what is left is x minus 4, right? Divide by x minus 2 square. So what are the critical points? Meaning, what values of x gives the numerator 0 and what values of x gives the denominator 0. That's what you are trying to see, okay? So if you take the numerator 0, f prime of 0 implies x equals to 0 and x equals to basically 4, right? And in the denominator, if you do f prime equals to undefined at, for what values of x gives you the 0 in the denominator? X equals to 2. So the critical numbers are x equals to 0, 2 and 4. But what is given there is, it is given that you need to look at the critical number only between -2 and 1. So what we can cancel there then? So between -2 and 1, this is outside -2 and 1, this is outside. So only 0, you will take only 0 there, right? So you will consider only at 0. So what we do is we look at the left endpoint, right endpoint, and then critical number. So what we do is we find out the value of the function, the given function at left endpoint. What is the left endpoint? Fx equals to f at -2, right? Because we want to find out the height of the function at left endpoint. So what do you get? You get 6 times -2 square, right? This is what you will get. You will get 6 times -2 square divided by -2 and then minus 2, right? What do you get? Is basically 6 times 4 over -4, right? That is basically -6. So you get, that is -6. Similarly at the right endpoint, meaning 1. If you plug in 1 there, what do you get? 6 times 1 square is just 6 over 1 minus 2 is negative. So -6 again. At 1 also you will get -6. Let me write down that. So it is -6. F at 1 is also -6. And at the critical point is 0 only, right? So plug in 0 there. 6 times 0 square is 0 and then over 0 minus 2 is negative. So 0 over -2 is 0. So which one is the maximum? Which one is the minimum? So global max is at x equals to 0, right? Because this is the maximum value of those, right? At x equals to 0, it is the global max and the value is 0 as well. So global mean at x equals to -2 and +1 and the value is -6. This is how we answer that. So basically to find out the global max or global mean, the idea is first find the first derivative, set that equals to 0, find the critical numbers. So for the critical numbers you find out two different ways, right? One is solve the numerator equals to 0. And if there is x in the denominator, solve the denominator equals to 0 and find out the critical number. Okay. If there is a negative exponent, you need to move that to the denominator and then solve the denominator for the critical number, because critical number are those values of x where the function is the first derivative is 0 or first derivative is undefined. And after you do that, you plug in the critical numbers and then all the critical numbers and all the endpoints to the original given function, and then see which one is the maximum and which one is the minimum, and in that way you will find out the global max or global mean. But when you plug in the critical numbers, plug in only those critical numbers that lies in the given interval or the given domain. Okay, let us look at the last example of this section. So does fx has local or global minimum? Look at this. Does it have local minimum? No, right? Because see, it looks like at C it must have a local minimum because it is decreasing and then increasing. So it looks like at C the height is the minimum one if it was continuous. But at C the height is a little bigger, right? So it looks like this point, okay, this point or that point will have the minimum height, but we don't know what that point is. We don't know what that points are basically. Because at C it is that point, and close to C there are points, but we don't know how much are those because they are the open. Right? These are the open there. So the answer is no for this. No local minimum, no global minimum. How about here? Here it is yes, right? Why is that? Because left to C and the right to C, all the heights are bigger than the height at C. This is the height at C. And left at C and right at C, the heights are bigger. Look at this. Right? At C, the height is the smallest one. So local and global mean at x equals to C. But here it is not. Why is that? Because at x equals to C, this is bigger than near the around C. But after that, other points have higher height bigger than that. Okay. So this is no and this is yes. Okay, guys. Thank you very much.